Welcome to part 4 of the No-Rise Analysis Training video series provided by the Kansas Department of Agriculture, Division of Water Resources. My name is Ben Ruffinaw with WSP and I'll be guiding you through this training. In this video, we will cover an example of a no-rise analysis for a proposed bridge replacement using 2D modeling. We will walk through checking the effective data. We'll walk through creating an existing conditions model and also updating that existing conditions model to the proposed conditions. And then we will walk through checking that the no-rise conditions are met by comparing the existing and proposed conditions models. For this example, we'll be looking at a proposed bridge replacement of a 70-year-old structure that they want to update to a newer design while keeping it as similar to the old opening as possible. So the first thing we need to do is look at the current effective modeling. We can go look at the effective modeling using either the Kansas Effective Floodplain Viewer or the FEMA Map Service Center. In this case, we're going to use the Kansas Current Effective Floodplain Viewer. If the proposed bridge makes any changes within the floodway, then a no-rise analysis or a lateral map change is required. And we can see here in the picture that the floodway ends just upstream of the bridge. But because changing the bridge in any way would impact the flood elevations in the floodway, we do still need to do a no-rise analysis, even though the bridge itself is not in the floodway. The next step is to track down the current effective modeling. We can do this by going through the Flood Risk Study Engineering Library from FEMA. If you need more information on using the Flood Risk Study Engineering Library, you can find the guidance document for the Mapping Information Platform, the MIP, to hopefully answer some of your questions. But if we run a search in the Flood Risk Study Engineering Library, we can find that third item in the search there is the current effective study. So if we click through that current effective study and download the data that is included there, we see that we don't have the modeling data for the stream that we are working on. So now we need to start digging through to find more information here. And if we look at the current effective flood insurance study, or FIS report, we can find a list of the sources of the mapping. And if we look on the stream that we're working on here, the Wakarusa River, we see a little asterisk by the name there. And we go see what that asterisk means, and it says streams not restudied as part of this countywide FIS, redelineation streams. We can dig into the text of the current effective FIS report and try to figure out what that table meant. And we can see here that the results of the previous modeling were just carried forward and the water surface elevations were replotted on new topography. If we want to dig further, we can find historic products from the previous effective modeling on the FEMA Mapping Service Center. Digging through these effective products on the FEMA Mapping Service Center, we can see that the previous mapping was originally completed in 1982 and then updated in 1993. So we probably are not going to be able to find the previous modeling for this stream. Referencing our flowchart from the FEMA MT2 request guidance, we can see that if there is no effective model available, we can skip directly to the existing conditions model. Before we go on and create our own new existing conditions model, we should check with KDA on the current mapping projects and see if somebody has already created an existing conditions model for us. We can see here on the project reference map that there are new studies being completed in the county we are working in. And if we navigate on through the site, we can see the proposed mapping updates for our county, and we see that the stream we are working on is currently being updated. The modeling for these current mapping projects can be requested through the KDA BFE portal. This portal is not just for requesting elevations, it can also be used to request the modeling. So we received the draft modeling from our BLE request through KDA. And upon inspection, we see that this modeling will work for the existing conditions model. So that will save us a lot of work on this project. Because there is no available effective model, we don't need to worry about the duplicate effective or the corrected effective model. So there's no extra checks to do for those two. And we can see here that the existing structure is represented in the draft model, and there's sufficient detail for our no-rise analysis. So we can just use this draft model as is for our existing conditions model. With our existing conditions model completed for us, now we can move on to the proposed conditions model. For this bridge replacement project, the only thing we need to change in the model is the bridge itself. So we can start out by just changing the geometry of the bridge from the old design to this new, more modern design. This new design does change the opening a little bit by making the piers a little bit smaller and spacing them a little bit wider apart. And also the deck is going to be significantly smaller, so it'll create less of a restriction there. Looking at the bridge in modeling scale, it becomes more apparent that the opening is definitely less restrictive. Now, luckily for us, the 100-year water surface elevation does not actually hit the deck of this bridge, so the changes in deck thickness are not going to matter in this case. Now, if those elevations were just a little bit higher, it would become much more difficult to meet the no-rise criteria for this bridge replacement, and it would probably just be easier to go with a full CLOMAR-LOMAR analysis to get this replacement done. Now, since the water surface does not hit the deck, the only differences between the two is the slightly narrower piers. Now that we have our existing and proposed conditions models, we need to compare the results to see if they meet the no-rise criteria. Now, in 2D modeling, there are two ways to compare the existing and proposed results. The first is to compare the peak water surface elevation computed for each individual mesh cell. The second is to compare the average water surface elevations across each evaluation line. Evaluation lines are what have replaced the traditional cross-section in 1D modeling. Now you can see from this image that these don't necessarily look like cross-sections, but what they actually are is just water surface elevation contours of the 2D modeling results. And because in 2D flow can go in any direction, they're going to follow the direction of flow instead of just going directly across the floodplain. In the floodway guidance document, FEMA has detailed how the mesh cell water surface elevation results and average water surface elevations across each evaluation line should be compared for floodway surcharge modeling. Now, it is not obvious in the guidance, but this same criteria should be applied to no-rise analyses. In the floodway guidance documents, there are 3 criteria that need to be met in order to meet the surcharge requirements, or in this case, the no-rise requirements. You'll see in the image there that there are 4 criteria listed. I've just combined items 3 and 4 into the same item. They're really saying the same thing in a different way. So the first criteria is the average evaluation line elevation must match within 1/100th of a foot. The second is that all cells that overlap insurable structures need to match within 1/100th of a foot. So 1 and 2 are that strict 1/100th of a foot criteria for meeting a no-rise analysis. Now there's a little more leeway for all other cells in the mesh. They have a plus and minus half a foot tolerance for meeting, as long as they're not touching an insurable structure and don't make the average across an evaluation line go above that 1/100th of a foot requirement. Comparing the water surface elevation results at each mesh cell is fairly straightforward now with the raster calculator that is built into HEC-RAS, RASMapper. You can set up the equation here just to compare the difference between the 2 plans in the model. We can set the color scale to show our strict 1/100th of a foot criteria in the results of our raster calculator water surface elevation differences here. And when we put our evaluation lines over the top of this color scale, it becomes pretty obvious that our model does not meet current no-rise criteria because there is more than 1/100th of a foot of difference across entire evaluation lines. So that means the average across those evaluation lines will be higher than that 1/100th of a foot criteria. Those results show that even that small change in bridge geometry with the piers being slightly more narrow was enough to bring our model out of compliance with that strict 1/100th of a foot no-rise criteria. So to fix this, we need to adjust the grading inside of our bridge so that the level of restriction in the new bridge design matches the existing bridge. These 2D models can be very sensitive to even small changes in the bridge geometry. So it can be tricky to get these models to meet that strict 1/100th of a foot no-rise criteria. It can take many iterations of small changes to that geometry, but these criteria can be met. Once we get our mesh to where all mesh cells are in tolerance and we think all evaluation lines will average out to be in tolerance, we need to actually compute the difference in water surface elevation across each of these evaluation lines. Now, this process is a little trickier than just the straightforward grid difference that we can use to check each mesh cell. FEMA floodway guidance says that surcharges calculated on evaluation lines should be based on averaging of all cells or nodes that intersect the evaluation line, and averaging should be done using a suitable weighting method. The appropriate averaging technique should be selected in coordination with the FEMA project officer and community officials. See Figure 9 for a sample schematic demonstrating the averaging approach utilizing a discharge weighting technique. This figure that we talked about earlier is Figure 9 that is talking about in that quote from guidance. The boxes there in 1, 2, and 3 show the process for doing a discharge weighted average across each evaluation line. Now, note that that quote says a suitable weighting method. It doesn't say that you have to use this weighting method shown in figure 9. This is just an example of what you can use. For our example here, we're actually going to use a length weighted average. So we're going to do it different than what is shown in figure 9. This is a little more straightforward because we don't actually have to know the discharge for each cell. To do this, we just need to multiply the difference in water surface elevation between the proposed and existing conditions on each mesh cell and multiply that by the length of the line segment that crosses each of those mesh cells. So you add that delta of water surface elevation times the length for each chunk here, and in this image you see each chunk is denoted by a different color, and then you divide that by the total length of your line, each line segment all added together. For our example here, we can actually simplify this into just 2 line segments. The segment that is over the teal colored cells has a difference in water surface elevation of negative 1/100th of a foot. And then the dark blue mesh cells have equal water surface elevations between the existing and proposed conditions. So our change in water surface elevation is 0. So to compute our average, we just take the negative 0.01 times the shorter line segment there over the three teal cells of 203 feet, and then we divide that by the total line length of 621 feet, and we get negative 0.003 feet. And we can round that down to 0. We're below our negative 0.005, so we can say that this evaluation line meets no rise criteria. So we can use that same method to confirm that each of our evaluation lines meets the tolerance of a change in water surface elevation of less than 0.005 feet, to round down to less than 1/100th of a foot. So once we do that, and we know that each of our mesh cells meets the plus and minus half a foot of tolerance easily, as long as we meet the evaluation line tolerance, most likely the mesh cell tolerance is easy to meet. And with that, we're not changing any of our mapped water surface elevations. So there's no need to do any kind of LOMAR or CLOMAR, letter of map change. So the only thing we need to do to permit this project is to get our state and local permits. We do not have to go through any FEMA floodplain review process because we are not changing the mapped floodplains in any way. Now, some important points to remember while you're going through these processes is always check the project area effective mapping products and check for any letters of map change in the model area. If no effective model is available, then you can just start with an existing conditions model. But always check with KDA to see if there's any future mapping updates that are underway, because a model may already be created that will work for your existing conditions model. If you do have an effective model, make sure you check against the effective mapping and FIS to ensure that you have the correct base model. And if you find any technical errors in the model, make sure you check with KDA to make sure these issues do need to be addressed and or were not already addressed. But in this case, you would do a corrected effective model. Make sure that you add sufficient detail to the existing and proposed conditions model so that you actually represent the proposed changes. Make sure they are well represented in the model. And remember that you have to compare the mesh water surface elevations and the average elevations across each evaluation line, between the existing conditions model and the proposed conditions model to meet the no-rise criteria. If your project does not require any changes to the effective mapping, then you only need state and local permits. If you have any questions or are looking for more information on anything that was discussed in this video, you can contact the Kansas Department of Agriculture, Division of Water Resources, Water Structures Program at the following phone number or email address. You can also check their website at the URL listed on the screen here.